Hello. So let's talk about one of the favorite question of any interviewer, factorial. By factorial, what we want to deduce is given an n value, we want to find its factorial. So for n equal to 5, the factorial of 5 is 120, and the way to reach 120 is through this approach. So you keep on decrementing up and until you reach 1, and you keep on multiplying the element that you have received. So either you can read it from top to bottom, or you can read it from bottom to top also, that is also fine. So basically you just keep on multiplying up and until you either reach 1 or you either reach the n value if you are reading from right to left, right? So we begin by simply writing for I in range of 1 comma n plus 1, where n is equal to 5, right? Here this will be factorial result. We initialize it with 1 and we do factorial result into equal to I. So the way iteration is working here, first of all we got 1, right? Factorial 1 got multiplied with the factorial result. This gave us 1 only. Then in the second iteration, the factorial result was of the value 1, and I value now became 2. So this is how we got 2 in the factorial result. In the third iteration, we will get uh, I value as 3 and factorial result was 2. So 2 into 3, that becomes 6, right? We then move forward. Now the I value became 4, and that's how we got 6 4s are 24. And finally we multiply 24 into 5 and we finally got 120. We can move ahead and print this. I'll quickly execute this. This is how I'm getting. Now there are some key consideration that you should not forget writing your code, and this might put you above from all the rest of the competitor. Is you need to consider the basic constraint. For instance, if the n is less than 0, then either print something in the um, error case, or just flag it basically. Okay. Now if the n value is equal to 0, or if the n value is 1, so in that case you do not need to go into this loop. You can simply print the factorial result as 1, as 0 and 1 factorial is supposed to be 1 only. So we simply write n is equal to 1, and we can write here, we can simply print this factorial result, right? Otherwise this is what we are supposed to get. This we can execute now in the else block. Now that we have implemented till this far, let us move all of this into a function. The factorial, this takes n in the argument. We can pass n from here. Sorry, n is equal to 5, right? Everything goes inside here. Factorial result is by default initialized with 1. If n is less than 0, we can print -1. This -1 indicates the uh, error case. Get factorial, we change the function name to get factorial. Now here we simply need to return factorial result. Otherwise in the else block we can move forward. Actually the one iteration is also not needed, the first iteration, so that's how even further you can optimize this. I'll again execute the code. We need to return this, and this is how we are getting, right? Now, you are also expected to know the factorial using the recursion method. So I'll move ahead and quickly write that recursion approach also. So the condition here remains the same. You can directly return -1 if n is less than 0. If n is less than or equal to 1, you can simply return factorial result. Otherwise, in the else block, what you need to do, you need to return it as n into get factorial of n minus 1. Okay, no need of all of this. Actually, you can avoid writing else block also. Only this much is also fine. I'll move ahead and execute this, and this is how things are working. So the way this whole recursion is taking place is, uh, initially you got n value as 5, right? N is less than or equal to 1. This condition is not met, so your flow reaches here. Now your n value is n, yeah, n value is 5. It gets multiplied to n minus 1, right? So whatever was the n minus 1, so with respect to 5, the n minus 1 will become 4. That will again call this function, right? Now the n value becomes 4, and its subsequent next get factorial n minus 1 become 3, right? So whatever time this get factorial is getting called, the n value is stored internally in the stack memory. That is how the recursion also function, right? So basically what is happening under the hood, 5 is calling 4, 4 is calling 3, 3 is calling 2, right? And 2 is calling 1. It is at this moment when 2 calls 1, we know that the anything in with n less than or equal to 1, we need to return 1. So for 2, we do get the end result as 1, and eventually the output of this will be 2, right? So for this iteration, the output of this will be 2. Now this 2 will get a return back over here. So for 3, when 2 was called, right, so the resultant became 2. Now this will get multiplied, 3 into 2 will become 6. Now 6 will get passed here, right? And now this will get multiplied as 4 into 6. This becomes 24. Now 24 gets passed here, and this will get multiplied. This becomes 24 into 5, basically 120. And that is how the whole recursion technique is happening. Okay, we can also consider implementing all of this factorial thing using generator. So let us utilize this basic implementation only for generator, right? So in generator we use the yield keyword, and the benefit of generator function is, it does, whenever any iterable is being executed, the whole list doesn't need to get reside inside your memory. It is only that particular iterable element that is being processed that reside inside the memory, and once that process is done, that gets released. So it is a memory efficient manner or a way to handle your large data processing, right? So uh, the changes that we would need to do over here is, once we have this, we need to return it like this. So this whole return statement will get changed to yield keyword, right? I'll use one library, deque, which is present inside collections, import deque, and I'll tell you why I'm using this. So now let me just call this thing get factorial to help you understand how this thing is functioning with the help for generator. When I call this get factorial using generator, let me rename this to using recursion. Here I will now get the generator object. In order to access what element I am getting, we need to use next, right? So there are next, there are pre in order to access that element. Suppose I wanted to check at every interval what is the resultant that I would be getting. So here, instead of yielding here, I can yield here, yield factorial result, right? And the way generator function is, it uh, basically halts your state. So whatever was the resultant, it will get yielded whenever you call list or any next element, and then again it begins uh, with where the execution stopped, right? So once I do this, and I have already utilized a list over here, and once I execute this, so this will give me all of the thing that was yielded. Now what I want only the latest element over to get the factorial of 5. So the way I can do this, I do not need the list and all. So for this we'll use deque. Inside deque we will pass the factorial generator object basically, right? And we will have max line equal to 1. So now this will give us the dequed object, dequed list, and we can now do dequed list dot pop. To demo you, we can I'll print this from dequed list, and result I'll print this. Okay, yeah. So that's it for this session.